Alright, so hello everyone. Okay, so this is just a recording for the complete discussion on the probability that we had last time. Okay, so this is for your reference, and then I'm gonna be adding more later on. Okay, so for the first, okay, so what is probability? So we will be discussing it in two pairs or in two sections. Number one is the basic probability and the use of contingency tables. So, first video we will be using discrete probability muna, and then contingency tables in the next. Okay. So, what is basic probability or what is probability? Okay. So, probability simply means, okay, is the when okay, so let's go let's first describe first what is probability. Okay. So first is that we need to recall that the set of all outcomes in an experiment is called a sample space. Okay, so let's say for example you have a deck of cards. Okay, all of those uh all of those here in the deck of cards, okay, is what we call the sample space. Okay, all the possibilities, okay, all of the possibilities on the deck of cards, okay, is what we call the sample space. Now if we're going to describe next what is an event is just the set of the things that you will be able to draw on the card depending on how many things you draw. So for this example, them drawing 5, okay, the items that they are able to get for each one, okay, the king, the ace, the jack, and the queen, and the 10 are all just events. Alright, so that's the first thing that you need to know, that um, any subset of the sample space is called an event. Okay, so everything that you are able to happen that is happening using the sample space or within the sample space is called the event. Okay, now next, let's see. Okay, any subset. Okay, yan. So same with the darts, the cherry eye within the darts. Okay, the middle one is what we call an event. The sample space is the whole dartboard. Alright, so I hope this is clear as an analogy. Now we're going to be formally describing the probability of an event is a function that shows the chances of such an event that such an event to occur. Okay, or let A be an event from the sample space S of an experiment. Okay. First rule is that the probability of that an event A occurs or P of A is always non-negative mathematically, always between 0 to 1. Okay, do not forget this. If you are being asked, okay, what is the probability of something happening? Okay, it's always what? It's always between, okay, 1 to 0. Alright? So it's between 1 to 0. Okay? Now, it will never exceed 1. Okay, 1 is the absolute probability, or meaning it will really happen. And 0 is the negligible probability. It means it will not happen at all. Okay? Now, the probability that the sample space S occurs is always 1. Mathematically, the probability of the sample space is equals to 1. Okay, this means that if you're going to add all of the probabilities of A happening within the sample space S, okay, it will always be equal to 1, which is in fact it's in action 4. If in if E1, E2, E3 are all mutually exclusive events, meaning they don't have something in common, okay, from the sample space, therefore the probability of all of them, okay, is equals to 1. Alright, so it's like P of S is like an area, okay, 1, and then the parts of each, for as long as they do not um, intersect with one another, if you're gonna put them all together, it's equal to 1. Okay? So later on, this will be very important as we solve problems. Okay? Okay, so let's see. So what is the probability of an event? So there are three ways to measure the chances, or the first one is the classical concept of probabilities wherein, okay, we use the probability of A happening or probability of an event happening A within the sample space of experiment is equals to the number of occurrence A has divided by the number of occurrence that the sample space has. Okay, so for example, okay, let's say for example for this one, okay, if A letter is chosen, okay, naintindihan to, okay, ito yung basic formula ha, this is the basic formula or the general formula for probabilities we call it. So most of the probabilities, if we're gonna be thinking about it, it's always like this, okay, it's always like this, so try to remember this, okay. Right, so let's go for the next example. Okay, suppose that the letter is chosen at random from the English alphabet. Find the probability that the letter is listed somewhere before the letter J. Okay, so let's try to solve this problem. Okay, so what do you think are the sample space and the events are? Okay, so let's say that the sample space is what? The English letters, English alphabet. Those are what? Those are A, B, C, D, E, F, up to letter Z. Okay? So, I'm gonna be, writing everything. Okay? So, just use your imagination for this one. Okay? It means that all of the English alphabets are inclusive here. Alright? Now, next is, what are we going to do? Okay? The next thing that we're going to do is, we're going to, what? We're going to, okay, get the probability or the sets of things that A, okay, or event A, or the event, this is just an event, let's say this is event E na lang, okay, that the letter before letter J is, okay, so what are the letters before letter J? So we have A, of course, B, C, D, E, F, G, H, and I, okay, so these are the letters before letter J. Now, if we're going to use the um, formula previously, wherein the probability of an event A happening is equals to the number of A, or the number of elements in A, and the number divided by the number of elements in S, no? Or in fact, this is E, or event E, we can say that we can also use this. So S, or the number of S, is equals to 26, and the number of E is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. Okay. So using the formula, the probability of E happening or the probability of event E happening is equals to the number E divided by number of S, 9 over 26. Okay? Alright? So, are able to do this? Okay, very good. So, try to check your solution first. Okay. Oops. Okay, so we have this. Okay, it's in the PowerPoint actually. Okay. So, let's try another example with the letters. Let's say, okay, I'll just erase this one. So let's say that I have another example so that you can dwell first. Okay. So let's say that we're going to find the probability, okay, of a certain set of special letters. Let's say all vowels. Okay, the probability of getting a vowel, okay, and a consonant, probability of consonant. Let's add more conditions. Okay, so let's find the probability that the letter is listed. Let's change this. I'll just erase this so that we can have, you know, more examples for this because it will help you guys to analyze further. Sorry for this. I'm gonna leave it one. So is, let's just box it out and just erase it. So let's have letter A. Okay, letter A. Let's change it in color so that, yan. Okay. So letter A. Um, the letter is a vowel. Okay. And then letter B, a consonant before M. And then C, let's have, we call this letters means, let's say a consonant after L. Let's say L. Okay, so let's solve. Okay, for the number first one, we have, okay, let's use green. Okay, first one, we have a vowel. So the probability that there is a vowel is equals to the number of vowels. Let's say vowels over the sample space. We know that the sample space is equals to what? 26. Okay. So we have, how many vowels do we have? We have A, E, I, O, U. So we have 5. So we have um, N vowels. N vowels is equals to 5. Therefore, we have what? 5 over 26. So this is the probability, okay, that we have a vowel, to get a vowel. Okay. Next is, let's have consonant. Okay, consonant before letter M. So what are those? So the consonant before M. Okay, so what are those? So we have A to no, it's consonant. No, so it's B, C, D, F, G, H, okay, J, K, and L. So how many are those? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 consonants before letter M. Okay, therefore, the number or the probability of a consonant before M is equals to 9 over 26 as well. Okay. Next is the consonant after L. Okay. So let's see what is the consonant of uh, after L. Okay, so let's have L after L. The consonants after L is what? L, E, L, C, K, L, M, N, O, P. So they'll have Q, R, S, T, U, V, W, X, Y, and Z. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 12. Okay, so we have the probability after L is 12 over 26, or simplify it to what? 6 over 13. Okay, sounds good. So we're good with that. So try to practice that. Can think of more, what do you call this? Yeah, think of more examples I'm gonna be preparing for this one. All right. Okay. Next. Okay. Yeah. Let's go through this. Okay. So from a starting bicycle deck. So the bicycle deck is the playing card or the playing deck. So we have what? How many? We have 52. 52 cards there. Okay. A poker hand consisting of 5 cards. Find the probability of holding 3 aces. Okay, the sample space is the set of all possible sets of 5 cards drawn from the deck. Okay, so it means that this time, if we have 52 cards in total, there are how many ways, okay, are we able to get such cards if we're going to draw only 5? Or how many ways are we going to be able to draw 5 cards from 52, no, from the 52 card deck? Okay, so this will be a little bit complicated, but it's actually just the same basic counting principle. Okay, so and then while the event A is the set of all possible sets of 5 cards with 3 aces, therefore the probability that the event occur is, okay, let's solve it one by one. Okay, so probability of the A happening is equals to the number of A over the number of S, or the number of ways to draw 5 cards with 3 aces, and the number of ways to draw 5 cards from the deck. Okay, so let's try to solve this. Okay, so remember this formula muna ha, the N of A, and this one that is very long. So it's the same thing, okay, but the counting is quite different. Okay, so let's first figure out how many possible ways, because that will be our sample space, how many possible ways can we draw 5 cards from the 52 cards? Okay, so number one, of course, we do not need the order. Okay, we just need to draw. Okay, so what we can do here is that the sample space is equals to 52 combination of 5. Okay, because out of the 52, we're just going to get 5 cards. Okay, just let it be muna, no? 52 combination of 5, that you don't have to try to solve it immediately, like what is the total number of this one, because it's a very big number. But for now, let's just let it be that 52 combination of 5. Alright? So, the next is, how many ways are we be able to draw, okay, draw from the 5 cards, we have 3 aces, and then 2 of whatever that may be, because we're being asked for the 3 aces. Okay, so to do that, of course, the number of hand, let's say hand, is equals to um, the sum of getting 3 aces, or the getting 3 aces, exactly 3 aces, multiply by getting any other 2 cards. Okay, any other 2 cards, it means that it's get the 3 aces and then the other 2 cards, whatever that may be. Alright, so to get this one, how many aces are there in total? We have 4 aces, no? Combination of how many are we gonna be getting from that? 3. Okay, 4 combination of 3 means that you have 4 aces, no? And among all of those 4 aces, we're just gonna be getting 3. Alright, and then what? Getting any number, any other 2 cards. So this means that let's take out from the 54 or from the 52 the 4 aces that we get. Okay, or whatever that may be. So we have what? 42 minus 52 minus 4 equals to 48. Therefore, we only have 48 cards left. Okay, if we're gonna be considering the 4 aces at all. Okay, so 48 combination of what? 2 means that the 2 is from the 2 cards that we're gonna be getting, because the 2 cards that we're gonna be getting is from here, from the rest of the cards where the 4 aces are taken already away. Alright? You understand? Okay, so if you're gonna be looking at it, 4 and 48 are the sum, okay, of 52. And 3 and 2 is the sum of 5. Okay? Has the sum of 5. Or okay? So therefore, that is the first clue that you have. So if you would like to check, you need to know that first part of your combination should be tallied towards the total number of combination ahead, and then your hand, or 5, okay, should also be um, adding towards the second part of the combination of the sample space. Okay, it's not always like that. There are several special conditions, but generally that is how it happens. Okay, so let's see. So the probability of holding three aces, is equals to, so we multiply these two, 4 combination of 3, 48 combination of 2, divided by the total, or the sample space, for a 52 combination of 5. So how many are they? So let me just get my calculator. Where is my calculator? Okay, here's my calculator. So we have 52. Oops. So we have 4 combination of 4 combination of 3 times 48 combination of 2, okay, 52 combination of 5. So we have 94, 95415, or a really little number. So can put it onto the fourth decimal place. Okay, so shift. Where is that? Oh, I don't have it here. Oh no, here. Anyways, it's 1.73. Oh, 607. So it's 0.0070, something like that. 17 ba 18 na ginamit niya dito? I think it's 736. Okay. Alright? The one in the calculator is what we call scientific notation. Okay. So any questions for this one? Let's do another example for the card. Okay. So let's try another one. I think this one is really fun to answer. Okay, so okay, let's try to answer another one. What if you're asked to, okay, I'll just put another slide, okay, for a while. Where is this? What if you are asked to, okay, what if you are asked like this? Okay, and I have 5 cards. probability of holding 3 royals, a 10, and an ace. Okay, so let's have this. This one is really nice. Okay, so what if you have like this? Okay, it's a problem. Oh, there's a problem. There. So there. What if you have something like this? Okay, a standard deck, no, in a poker hand consisting of 5 cards. Now let's make it a little bit difficult. Okay, you have 3 royals, a 10, and an ace. So this is a what we call a royal flush, I believe. But we're not gonna be considering the suit. We're just gonna be considering if it is 10 or not, or a 10, an ace, and 3 royals. Okay. So how about let's check. Okay. So again, we have the number, the sample space is equals to what? Sample space equals to 52. Okay. Now our hand will be composed of several items this time. Okay, we have 3 royals, a 10, and an ace. Okay, this means that for our hand, we have what? First combination or the first item is 3 royals. How many royals are there? We have what? 3 for each suit. So we have 4 suits. Then we have 3, 6, 9, 12. So we have 12 royals, combination of 3. Okay? I'm not saying that the one is the king, one ace, or one heart. We just need 3 royals for now. Later on, we'll be computing for that. No, that will be a very different problem. Okay. Next is that among all of those royals, no, we need to have a 10. So we have 4 10s, combination of 1. So we're just gonna be getting 1 from that. And then an ace. So another 4 combination of 1 again. Okay, and then we divide it by the 52 combination of 5. Okay, so remember 12, okay, plus 4. Okay, 12 plus 4 plus 4 is equals to 16 or 20, and then 52 combination of 5. Now, sir, what happens to the other one? So we need to have what? We need to have total of 52, di ba? Like what we said. Now, this one is the exemption to that rule because all of the hands, okay, all of the hands are already described. Okay, so we have 3, 4, and 5. This is the fifth part of your hand. Okay, so it will not be total. It means that this will be a smaller probability compared to what we have earlier. Okay, so for as long as the 3, the 4, and the hands are all connected to 5, okay, that's okay. No, if this one is not connected with the 52, that's still okay because we're just dealing with what? With 5 cards. All right. Okay, so let's see. So we have n of h is equals to, okay, let's see how big that boy is. Okay, so we have, so we have 12. Oh, oh no. It's really hard to do this. 12 combination of 3 and 4 combination of 1. Yeah, so we have 0.00135. So 0.001345 ba yan? 13. I think 13 is okay na. 135. 135. And then, this is the probability of it. Alright? Okay, so let's have the second use of probability. Okay, the second is the use of relative frequencies. Okay, this one is quite, ano naman siya, uncommon naman siya. So we have frequency. So FA represents the number of observations that belong to event A. Fs represents the total number of observations in the experiment or the survey. So let's say, for example, we have a collection of balls. A collection of balls or mga bola. And then, yan, ang total collection natin. So, total collection, total number of balls is equals to, yan, 20. Now, we have a composition, for example, of the 20 balls of red balls, which is 5 blue balls, which is, let's say, 10, and then black balls equals to, yan, ano siya, 2, and then yellow equals to 3. For example, ganyan siya. So, total kunyari ng 20 to. Okay. So, the probability of the frequency divided by the total number of frequency. Okay. For this one, Fs is equals to 20. Okay. So, how many, let's say for example, what is the probability? Probability that one black ball is drawn, okay, or is picked up. Okay, so what is the probability? So to do that, we need to know the probability of the black ball. So we have 2. So the probability or the number of black balls is equals to 3. Okay, then the total number of balls is equals to 20. So therefore, okay, for this one, it is equals to 3 over 20. Correct? So it's supposed to be 3 over 20. Okay, because that's the total number of black balls and then the total number of balls within. Okay, so the frequency of that black ball is 2 pala, sorry. 2, 2, 2. No, I'm looking at the blue ball. 3 ito yung 2. Sorry. Anyways, yan. Okay, so we're looking at the event wherein there are black balls. So we're just looking at how many black balls are there. And then all of them are grouped as balls. They're just colored. Okay, so gets. So I hope you get this one already. So next is we have third issue is the subjective assessment of an educated guess of the chances an event will occur. So this one are quite special because these are um, hypothetical in nature. So we will not be dealing with that. Okay, so just be dealing with the historical, no, and the one that we do as empirical. Okay, so let's answer and so exercises for this one. Okay, a coin is tossed 5 times. What is the probability that? Yan, okay. So we'll be answering this on the next video. All right. So take care. God bless. Because it's already too long. We're gonna be doing this in the next video na, ha? All right. I'll see you.